Hello grade 12, welcome to my channel. Today let us look at some Euclidean geometry specifically for grade 12s. And let us just do some work. This was literally homework to one of my students. So we've already worked through this problem. But I figured let's just share some of these questions to assist someone who needs some good look into these kinds of questions, especially if you do not own this particular book. I don't know what book this is, but I think these questions that we're going to discuss here are pretty intense. So without wasting any time, for those who are writing during these May June exams, you may need this, you don't know, but in the channel, guys, I've done multiple past exam question papers that I've done from the beginning to the end, so there's no way I can finish all the question papers. You need to practice those. You get stuck, hit me up, I'll look into those. Now, we're given here a triangle ABC, as we can see here, and the additional information is such that FE is parallel to DC. We can see the FE is parallel to DC and DE is parallel to BC. So DE is parallel to BC. That is indicated. AF is 4 centimeters. Mind you, this is centimeters, so don't forget. And then DF is 6 centimeters. AE is equal to 8 centimeters. Now the first question says determine with reasons the length of EC. Okay, so for us to work this one out, so maybe let's just write it nicely and say this is question 1. Okay, so in question 1 we've got 1.1, which is subdivided into 1.1.1. Now we need EC. So what triangle is the best? The best triangle that we have most of the things is ADC. So you need to know how to look into this diagram and work things out. So in triangle ADC, okay, what do we see there? We can see that line FE is parallel to line BC. That means those sides AF over FD should be equal to AE over EC using the proportionality theorem. So we can just run into that. What are we looking for? EC. So we can just easily write here that essentially AF over FD should be equal to AE over EC. So let's see what is the reason here. You always need to write one. This is the proportionality theorem. Now you need to mention which sides are parallel. So in there we can see that FE or EF is parallel to DC or CD. How you want to mention this is really not a big deal. Okay, so let's substitute. AF is 4 over FD 6 equals AE 8 over EC. That's what we want. And then at this juncture we can do cross multiplication, or you can simplify that. It's really not a big deal. This implies that we've got 4 times the EC is going to be equal to 8 times 6. Therefore, you divide by 4. Our EC is going to be 8 times 6, all divided by 4. Now, what is that? Let us find it out. For me, 4 goes twice there, right? Then 2 by 6 is 12 centimeters. Remember, the final answer must have a unit of measurement. So very easy stuff. So essentially that's what you do. So for stuff like this, you're most likely getting 2 marks. And if someone wants to be generous, they can give you substitutions, but you hardly really get marks for substitutions when things are obvious in Euclidean geometry. So most likely 2 marks, at the very least 3 marks. Okay, let's move on. Maybe not here, but probably here. So I'm going to put it in brackets. You may get this mark, you may not get it. It's not a big deal. So 1.1.2 says we need the length of AB. So AB is on which triangle? ABC. So that means we need to find stuff on triangle ABC. So in ABC, what do we see? We can see that, look, we don't know AB, but we know AD. We also know AE, and we possibly can find AC because we just found EC right now. So that's 12 plus 8, it becomes 20. So we can essentially use that quality as well and say, look, AD, maybe AB over, now we're saying the whole side AB over AD should be equal to AC over AE. Again, prop theorem with basically DE parallel to BC. Great, so this implies AB is what we want over AD is now 6 plus 4, that becomes 10, equals AE, that's 8 plus 12, which is 20, divided by AE, which is 8. Okay, great. So we can simplify these things if we want, but I don't really have the time, so I'm just going to cross multiply the 10. I don't need anything else. So AB is going to be 10 times 20 over 8. Great. And maybe I can even make that my conclusion. So what do I know? 4 goes how many times here? Goes 2 times. And then here, how many times? 4 times. No. What did I say? 4 goes 2 times here. And then here goes 4 times. 5. 5 by 10 is 50. 50 divided by 2 is 25 centimeters. Sometimes so statement and reason in Euclidean geometry is the most powerful, and that's the mark. But usually if you look at 20, you had to calculate that 20. It wasn't given, so that's interesting. And if you look at that, it was calculated. So because of those, you may be warranted a 3rd mark for substitutions of what were essentially calculations on their own. So do you see, sometimes these is the ways in which marks could be distributed, but obviously this is from the textbook, so usually no marks are allocated here. But if you look at these textbooks and you look at some old exam question papers, you will find out that these were questions in the previous exams, like back in the days, even when I was myself a student. You may find that these questions are coming from that far back. Okay, let's do 1.2. 1.2 says now, determine the ratio of the area of AFE and the ratio of the area ABC. So what we can see here is that angle A is common. So we can use the area rule because we want to eliminate things since these don't look similar. But because of that common angle A, we can do that. So obviously we can say here area of triangle AFE divided by, so once you see this it means divide, or once you see this means a ratio. So a ratio is when you divide, so this is divided by area of triangle ABC is going to be equal to, how do you do this? Now we know that that is the angle, so the area rule says you multiply half times the product of the two sides and the included angle, sine of the included angle. So this is going to be half times AF times AE times the sine of angle A. I'm choosing A because it's common so that I can eliminate things. So this is going to be half, again, AB times AC, and that sine of the included angle A. Now obviously this thing means division, so essentially I can already eliminate half and half, sine A and sine A. So this is basically going to be equal to AF multiplied by AE divided by AB multiplied by AC. This is equal to, now AF is essentially 4 units times AE, which is 8, divided by AB. What did we find AB to be? 25, ne? So this is 25 multiplied by AC. We found that to be 20. Right. So now, what do we know? This is 32 is 225 by 20. Let us see. This should be 500. Ne? My answer's Tembanga. 25 times 20. Yes. Now, basically 32 goes to itself how many times? But 500 doesn't divide 32, does it? No, it does not. So basically, it's a different story now. It's a different story. So we can use 4. Ne? Let's use 4 instead, because I don't think 8 also. Yeah, let's use 4. 4 goes to 32 8 times. 4 to 500 goes how many times? 125 times. Ne? Yeah, 4 times 125 is 500. So that is the ratio. So sometimes I like to leave things the way they are given to me. But now all you needed to know is that this shenanigan means division, means a ratio. Okay? So this is not a semicolon. I'm going to try colon. Yeah, I got to try colon. I don't remember these things. Sometimes my grammar is wrong. This is a colon. So once you see a colon, you mean a ratio. A ratio means division. So this is why I'm able to cancel things side by side across the sign. So guys, you need to know maths, man. You need to know maths. And usually the way the question is phrased, you try to give the answer in that manner. Don't change it and write 8 over 125. You're going to bend. But literally you're just saying 32 over 500, which is 8 over 125. But you just write it in the manner that was given. So obviously, guys, Here we needed to use the area rule. So using a particular rule in maths is very key, right? Literally, the substitutions, we are substituting what we already have. So it's not a big deal. So the answer is here. So you can get 2 marks there. But perhaps, because we chose the sign rule for 2 things, we can say here both the left and the right probably get a mark. And literally, we can say you're getting a mark here. And yeah, that's it. You can get a maximum of 3 marks here. If they want to be generous, they can give you 4 marks for this step right here. Either way, we are good. So this is how easy you can go about this thing. So let's look for another problem so that we can end this. Okay guys, so here is another problem that we need to solve. Maybe let's just start it on a new page, just for fun. So we can see this is a question 2, so we can make this a question 2. So I hope at the end of this video you will have found some good practice on these questions. Now let's dive into it. We are given a triangle PQR with A on whatever, on PQ and S on AQ and whatever. So this one, no need to explain, you just look at it. Now what do we see? We see that W is the midpoint. So now that is very important. W is too thick. W is the midpoint of PR. So if that is the case, it means here we are cutting PR into 2 equal parts, meaning PW is equal to WR. So that is very important. And then ST is parallel to QW. We can see that ST is parallel to QW. It's already indicated. And WA is parallel to RS, again already indicated. And PQ over SQ, now that's good. PQ over SQ. So this is something we need to look at. So PQ, right, over SQ is 7 over 2. So that means if we say 7a here, always choose a multiple because this is a ratio, it's not units. And as lo a kutheni efuna ungiqhela nje 7a, then it means this one is going to be 2a. Okay, not 29 but 2a. So that when we do the ratio, then the a's cancel, so we get the values. Those values are not units. Be careful. Once you get a ratio, don't make it units. Then W and SR intersect at V. We can see that. Great. So what is the story now? The story is, look, if this entire side is 7 and this one is just 2, therefore it means this one, PS, should be 5a, right? Because 5 plus 2 should give us 7. So here a little bit of logic is necessary. So masibhale ngenyikhala yabo, sithi 5a. So logically, if you look at that from just logic, if the entire side is 7a with that small portion is 2a, therefore PS must be 5a because it's on the same line. So a lot of analysis, guys, you can never run away from it because it helps you to go through smoothly. Now you can see some people are trying to work here, so it's a bit ugly. People must never do this on a little thing, you know. They mustn't. Must leave the diagram clean and just draw one on the side, then work on it. But I am allowed to do that on the screen here because I can rub it off at the end. Anyway, now 2.1 says, with 2.1.1, I must determine with reasons PT over TW. Can you see? PT over TW. Now if you look at that, this, when I look across, I know that PA, I can calculate it to be 5A, and SQ is 2A, was already given. So in that triangle PQW with ST parallel to QW, I can use my proportionality theorem. But obviously I need to account for that PS in a way. So you can see this is now becoming a bit challenging. You can't just jump in. You've got to put some thought in it. Okay, great. So what are we going to say? We can say here in triangle PQW, because you need to identify the structure. That will help you. So what do I need here? I need to indicate that PS is equal to 5 portions of this thing. Obviously, you will have indicated these things on your sketch. So you can just easily say C diagram. At times, you just don't want to say too much, okay? It's by logic or it's by inspection, but provided you indicated these things on the diagram. If you did not, then you are just killing yourself. So I'm showing you how you answer these questions adequately, because whenever you are given a sketch, work on that sketch, but let it be neat so that someone can see what you did. Now we can say here then, we know without a shadow of a doubt that PT is what we want. So PT over TW is going to be equal to, now what is that? The other side is going to be PS over SQ. Now what is the reason here? This is the proportionality theorem. What is the story there with ST parallel to QW? Easy stuff. Can you see? This is nice, guys. And then now we can say this implies that PT over TW is equal to PS is 5A over here you can say SQ, which is 2A. Right. Then the A's cancel. And therefore we know that our PT over TW equal signs. From here you just drop the equal signs in the left and the right hand side. You are fine. So this is 5 over 2. Nice and easy. Nice and easy, guys. Nice and easy, guys. Nice and easy, guys. So that ratio is good. So can you see? You needed to show this. But someone who is smart, okay, let me not try to be crazy here. Literally here, this particular substitution here, if you did not already say it here, you could actually show a calculation that, let me write it differently. You can write a calculation that is going to be 7A minus 2A. Because literally it's going to be 7 minus 2, so it leaves PS. So you may not need to say this statement and just substitute this in the space for that business, and everything is just going to work out smoothly. So always be as creative as possible. Sometimes it helps. So here we get a mark for a statement and the reason. But as you can see, this was a calculation on its own. So we can literally say, look, for correct substitutions here, we could be very generous and give you an extra mark for the final answer. Or we say there's 2 marks and give you the mark there. So it doesn't matter. 3 marks is probably going to be scored in a question like this. 2.1.2 says now we need to find PT. Can you see PT is this one? All right, okay. Let's do this first. Now, on our diagram, we already found out PT is 5 over TW. So we know that this lovely portion here is 5. Now we need to choose a multiple. We can use B. And then this is going to be essentially 2B as well. So we need to choose a multiple different from the others because these are not equal, but they are proportional. Great, so that needs to be there. But now look at that. What is PW? PW is literally 7B. But what were we told? We were told that this W is the midpoint of PR. So this makes this side literally 5 plus 2, which is going to be 7B. So that is also important. So whenever you are given information, guys, always try to find something, update your diagram, and try to apply as much logic as there is provided for you to play around. Okay, now this one, we need PT. Can you see PT is 5B over TR? Can you see TR now is going to come out as 9B? But we need to make an account for this WR. So essentially we can say we know that PW is equal to WR, or maybe let's put it this way. Say WR is equal to PW. Why? We know that W is the midpoint of PR. This is important. So now what is PW? PW is made up of PT plus TW. This is 5B plus 2B. This is going to be 7B. Obviously, I'm just stretching your mind here. If you've written those things, you don't really need to show this long, lengthy thing. All you can just do here, you will just simply say 5B plus 2B, which is going to be 7B. Ne? That is important. We then say what? PT. Some ratios you need to look at directly over TR is going to be, what is PT? Is 5B divided by, now TR is going to be 2 plus 7. So you can write 2B plus 7B to suggest that this is a calculation on its own. This implies that our PT over TR is going to be 5B divided by 9B. Now the B's, they do their thing, which is going to be just 5 over 9. Can make the conclusion. So don't be lazy to write, guys. But if you are lazy, you just drop the equal signs in the right hand side. You are done. It's easy. You know, guys, a teacher of mine who taught me maths some years back said to me, if I have equations that I'm working on, as I follow the steps, my equal sign should almost follow a straight line or a vertical line. So this jumping around was not really, accepted or acceptable. It was frowned upon. So you needed to make your equal signs to flow straight down nicely so that the work is neat and one can separate things. Even you get helped by not mixing things up. But anyway, that's just something, That's just something. So here's the thing, guys. What matters here is to find WR. because without WR it would have been painful to do this thing. 2, we needed to find this value for okay, this TR was also a lovely calculation on its own, so you get a mark for that and the answer. So most likely 3 marks here. This was given, so you're not gonna get a mark for it. You didn't realize it was provided to you. Excellent, brilliant. So what is the next story now? The next story says we need PA over SQ. So can you see now this thing is jumping around, it's trying to give us a headache. Yeah. Whew. Okay, how are we going to handle that? Is it possible to squeeze this thing in here? Because what it's asking you and I is to find PA, isn't it? Because we already know what SQ is. So we need to play a very clever game. To find PA, we need to use which triangle? We need to use this triangle, right? That's what we need to use. Whew. Oh, yeah. No. We don't need to. Yeah, we do need to use that triangle, PSR. Because remember, if we are told this double is the midpoint and this line is drawn parallel to this side, the midpoint theorem tells you and I that that side is also equal to that side in that triangle. So essentially, we know 5a, if we divide it in half, it's going to be 2,5a. So I think we can squeeze this one here. So 2.1.3. So can you see you are using even theorems from grade 10, guys? Don't forget. Euclidean geometry is going farther than just the topic at hand. If you're doing proportionality theorem, it's going to be pushing you to things like, parallel lines, vertically opposite angles, cointerior angles, midpoint theorem, and all these other circle theorems as well. So be very aware. So now we can say here, we know that in triangle PSR, I was actually thinking of performing a calculation here, but I knew it's going to be a very cumbersome exercise. So what can we say here? We know that in this triangle, PA is certainly equal to PAS. Why are we doing that? It is because of the midpoint theorem. Now, when you say midpoint theorem, you're applying this in this triangle. As you know that this triangle had a side divided in half, and the line drawn from that point across parallel to the other side, the third side, it should also cut the other side in half because these things are proportional. But what needed to come out was the midpoint theorem of triangles, because this midpoint theorem is of triangles. Maybe I should even indicate that. Say midpoint theorem of triangles. Because you don't use this elsewhere, do you? Unless I'm crazy. But who cares anyway? Some things are just the way they are. Okay, so that is great. So what does it mean? We need PA here. We can say this implies that PA is going to be essentially half the size of PS, because we know that PS is divided in half, therefore it's going to be as that. So we can say technically PA is going to be half of PS is 5A. Great. So half of 5A is basically 5 over 2A. So maybe let's just not waste time here. Say this is going to be 5 over 2A. Okay, easy. we can say then we can go for this ratio now, PA over SQ is going to be, PA is 5 over 2A. Now this line is a division line, divided by SQ is just 2A. Now if we've got fractions, this is over 1. This is going to be 5 over 2A multiplied by 1 over 2A. Now that cancels. Then the numerators multiply, the denominators multiply. So what do we get? 5 over 4. That is the answer. That is the answer. So, see, maths, guys, is beautiful. Mathematics is just a subject of so much wonderful things. Now, this one you needed to realize it's a powerful statement. You needed to come up with that. And 2, we worked out PA. It was a calculation on its own. Then when we get to this ratio, no one is going to give you a mark for other things, but you get a mark for the answer. So most likely 3 marks also for a question like this. Under standard conditions, of course. But examiners remain examiners. They can do their own thing. So be careful. Don't try to think what they think. Just do what is standard. You will not go wrong. So 2.1.4 says we need to find QV. QV, right? Over VW. So how do we calculate those things? Now this one is a naughty one, isn't it? Because now we just don't know how on earth that is possible. Yeah, doch, kill me already. I don't know what I would do there. But here's the thing, guys. We know that this side, QW, is part of these triangles here. Remember that whole triangle PQW as well as PST. Now those are similar triangles literally. Even though we are talking proportionality theorem, technically if you split this into 2 triangles, those are similar triangles. And we know that their corresponding sides are in the same proportion. So we can use that because it's going to have ST and QW included. But at the same time, what else uses ST is this triangle over here. So always try to find something common when it is going to involve a side that is probably crazy and exotic. Try to find what should you link together in what way. Now if you look at this ST in terms of this triangle RST, you will see that it is essentially corresponding to VW. And VW is part of this business right here. Now we've got VW, but remember we're talking about QV, but we're finding VW showing up as a part of this QW, and it's also showing up alone. So that means technically, we will be able to do something here. So let's just look at those 2 triangles. This triangle PQW and triangle RST, because we know that ST is somehow showing up. So we want to try and derive some simultaneous equations here. Remember, even though this is Euclidean geometry, you will always face simultaneous equations somehow. Okay, let's start here. We can say in triangle, it doesn't matter which one, honestly. Let's just say RST. Triangle. I know without a shadow of a doubt because I am interested in what I know. So the sides that I know in this triangle is these sides. And the sides I don't know is this VW, which is part of what I want, and ST, which I could see can be common in these 2 triangles somewhat. So I'm going to use the side that I know and the side that I don't know. So I can simply say RW, rough work divided by VW is going to be equal to, remember these are similar triangles, or even proportionality theorem allows you to do this. This side over that is going to be this whole side over that, because it uses similar triangles in terms of their corresponding sides. So this should be the same as RT over ST. Here you don't need to use similar triangles because they are in one triangle. You can just simply say proportionality theorem, because proportionality theorem and similar triangles is the same thing actually. Prop theorem. What do we know? We know that VW is parallel to ST. Okay, so proportionality theorem and similar triangles is one and the same thing because we get ratios, right? Right, so this is applicable, so don't panic. If you are given a triangle with one side parallel, just say prop theorem. If you've got separate triangles, just use similar triangles. Easy. Okay, great. So, sorry. So RW is what? 7B over VW, we don't know. That's what we want, is equal to RT. RT is going to be 7 plus 2, so it's going to be 9B over ST is what we want. We saw that it's going to be common, so we can keep it that way. So this is literally substitution. So what can we do here? Well, we know that we want ST because we saw that it is common. So let's try to isolate ST here, because we can see this one is going to be common also on the other side. So this implies that ST times 7B is equal to 9B times VW. Ne imotos ga VW amavrupa. Okay. So therefore, when we divide by 7B, we can see that ST is going to be 9 over 7. The B's will cancel, times VW. Great. So that's great. That's an intermediate answer of some kind. So we leave that alone. We can say also, in triangle, we saw that this triangle PQW has something to offer us. So we always try to look for connections, guys. In maths, believe me, the most difficult questions, it's all about those hidden connections. What can we say in this triangle? We know that, look, we can apply the same thing here. So we know any side, so we can choose any side that we know. But what is key is that we want ST and QW to come up, because we've got some stories there. So let's just go on and say, look, PS over, now this side ST, because we're using the concept of similar triangles, must be equal to PQ over QW. Okay, why am I choosing QW? Because I know QW is made up of QV plus VW, which is the stuff that I want, isn't it? Yes. What is the reason here? Same reason. So don't write same reason, write it prop theorem and state the parallel sides. It's ST parallel to QW. Easy, guys. I'm working through this nice and easy so that you can follow. Sometimes some questions are higher grade questions, okay, by nature. But sometimes you may find that I'm crazy. There's a quicker way, so it doesn't really matter anyway. Whatever you saw, stick with it. Now, what does this imply? PS, PS is basically 5A, we found out, over ST, we don't know. But we know there's something about ST above is equal to PQ. Now PQ is 7A. So do you see? Over QW, but now QW is literally a crazy story. What is it? It's QV plus VW. So okay, so it's getting interesting. Now we have a plus in here. It is maths, baba. Iyamethula, imaths iyamethula. Ayidlali senze gymnastics ke ngoku. Our favorite gymnastic, isn't it? So essentially, technically, and you know what? Zonke bonke. What is the story here? What is the story here? What is the story? The story is like this now. We've got this 5A into QV plus VW. Just keep those in brackets so that you don't run into problems. We've got 7A times ST. Ingati ifuna uvuthwa lento. Then we divide by 5A. What do we get? We get QV plus VW is equal to 7 over 5 times ST. The A's will cancel. So I'm moving a bit faster now because I'm taking all the time I didn't want to take. Okay guys, so now eating nalento. This also implies that now QV plus VW is equal to 7 over 5. Now what is ST from above? It's 9 over 7 VW. Sesiya substitute again ngoku. Yayiva ke ngoku imaths imnandi bantam. QV plus VW is equal to, now we fold this thing out, 7 by 9 is 63, right? I'm sure 7 times 9, yes, is 63. 5 by 7 is 35. Then VW. Now can you see we've got VW everywhere. So we can just decide to eliminate the VW because we know that we want the VW to be on the denominator. So we can divide here. Doesn't matter which side you choose to start, but what you do on the one side, you must also do on the other side. It's just that now it's a bit silly. You're starting from the other end. So this goes, and it leaves us the ratio that we want, is it not? Yawena. Oh, people did. Disenze maths ngo higher grade back in the days. Nisalele nisadla ubuthongo. Ningazwa noba nizoba khona. So this is 63 over 35. Great. So now we transpose the 1. We can say therefore QV over VW is going to be 63 over 35 minus 1, which is going to be equal to, now just take 35 and multiply there. What is it going to be? It's going to be 35. Therefore we get 63 minus 35. It gives us 28. Right. So now we get 28 over 35, which is going to give us things like this, 4 over 5. Right. So can you see that ratio is out and about? Maths geleyo. But yeah, this one is a suplex city. Unless honestly there's something I am missing. It's always easy to miss some things, you know. It's always easy to miss some things, but for me, if you know what you are doing and you can follow it up all the way, I'm most happy because it says to me you understand your work. So literally, guys, this statement is key, right? Right. And obviously getting this guy should be an important technique. But this thing is similar to that. You're not going to get a mark. It just justifies what you are doing. Ne? But now what is key is this. You see this QV plus VW. That was a bit of a calculation in a way. You get a mark there. The rest of the gymnastics, guys, is your own indaba. But now what is key is this substitution here of ST. Right. So let's see what is the story now. We've got 1, 2, 3, 4. Yeah, this one should be 5 marks because the rest is just mathematical gymnastics. So you're most likely getting 5 marks for this question. And you can see it's a bit of a suplex of some kind, but you needed to be smart and understand that simultaneous equations also apply in Euclidean geometry, whether you like it or not, Okay, let's continue, guys. There's more questions here. We've got 2.2. I see before this hour is down. So 2.2, we've got 2.2.1. We know we are told here SR is equal to 36 centimeters. So 2.1 says let's find the length of AW. So now where's AW? AW is this side. We are given SR. So from the midpoint theorem, we know this side is going to be half of SR. So this is great. So we know now what we want, AW. Okay, maybe let's start by saying things. That first in triangle, PSR, because that is the midpoint theorem applies in that triangle. We know that essentially AW, which is what we want, is going to be equal to half the size of SR. How do we know this? Midpoint theorem of triangles. Understandably so. So don't complicate this reason. Leave it as simple as that. We can say this implies that our AW is going to be half of 36. Therefore, our AW is half of 36 is 18 centimeters. Easy. See, so essentially this statement is powerful and the answer. So here you're getting 2 marks. This substitution, it's weak. In Euclidean geometry, it's not really the biggest thing, but when something is a determination of some kind, it becomes heavy enough to score a mark for a student. So 2.2.2. Eating we must find the length ka VR. Wow. How do we find the length of VR now? Okay, maske sijonge. Oh, yeah, we can use it. We can use this triangle RST. So we can say in triangle RST. So you can see, guys, I always name the structures I'm working on to direct even the person who's looking on as to what I'm doing. So please be in the habit of, don't just drop ratios and proportions that you don't know where they're coming from. Because now it becomes very fishy. Did you copy from your neighbor? Do you even understand what you're doing? It becomes very difficult to award marks to a student who probably doesn't get the right answer, but perhaps started somehow correctly because you wondered, do they even know what they were doing? And you don't reward marks for someone who's totally lost. But if you know exactly what you're doing, then I can say it's a mistake or there was a lack of understanding going further. At least I'm convinced it's your work. Then you get marks where you're supposed to get them. So please, guys, what I'm showing you is not for fun or it's not optional. It is a must if you want to survive your maths without any difficulties. I know some of your teachers are a bit complacent. They are not really particular about the method of doing these things, and yet they should emphasize that more than anything else. because that is what makes you lose marks. Remember, not all the teachers who mark your scripts are the best mathematics teachers. So they rely on the memorandum. Sometimes if you start saying things they cannot follow, and if you happen to go wrong somewhere, then they start causing trouble for you. So be very careful. There are not so many good teachers in the subject that would know how to really reconcile some issues that are done by another student. And also, remember, it's a pressured situation when they're marking those exam papers. So they want to finish and get away. So if you give them a difficult situation, then you're most likely going to suffer as a result. Anyway, enough of the nonsense. So what can we do in this triangle? We can see that VW is parallel to that. So proportionality theorem can come like this. We can say VR exactly what we want over. Now here, I don't know VS, so I can use the entire side RS. Is going to be equal to, on this side is going to be RW, a rough work, over RT. Here we're using the proportionality theorem. With, always state the parallel sides, VW parallel to ST. This reason is not complete with just prop theorem. We need to understand how are you applying this. It's only when this is the constraint. So you leave constraints. So VR over RS, we were given it's 36. RW, we can just say this is just 9B. Ne? It's 9B. Because it's basically RW is 7B. You went superb. 7B. So this is imag tingathi happy nje. Andikho happy man. Khona izinto ezingenza sense apha. ORT bavelaphi. Yho. Yabona ke ngoku. Yabona ke ngoku. Oh, the right man, the right. RT is 9. Yo, then there's confusing. Sending any question. So this is RW, which is 7, yeah, 7B, over RT, which is 9B. Okay, so the B's, because this is a ratio, they already disappear. And then you just cross multiply that thing. So VR is going to be 7 over 9 into 36. What is that? So 9 to 36 goes 4 times. Ne? 4 times 7 gives us 28. Remember, this is centimeters. Phew. Yankulu nanzi indo. Inkulu kakhulu kathi ngibe sure sometimes khona nje ke ngaqini komnqwazi 36. Yeah. 20 whatever. 8 centimeter. Okay, that one was not a big question per se. We've been singing this prop theorem. Honestly, guys, I'm not interested. But here, what is interesting is some of the substitutions here. You see, this one was a calculation in a way, while this one was pretty straightforward. So essentially, I can say correct substitutions and the answer. The reason is weak now because we've been stating it and we've used this triangle multiple times, but it has to come out to justify what we are doing, but it's not really heavy. Okay guys, last question. So your English lishile foot 2.3 says determine the area of PSR. So this triangle divided by the area of triangle WVR. Can you see angle R is common? So we use the area rule here. So we can say area of triangle PSR. Can you see we did this above? It's coming back again over area of triangle WVR. This is going to be equal to half the sum of the sides that include this angle R. Is going to be basically RS times basically RP or PR PR times the sine of angle R, because we can see that angle R is common to both triangles, so we want some elimination. So this is going to be half, here the sides is VR times RW, a rough work, times the sine of angle R, which is the common angle. So now we wanted to do this business. It is done. It is done. So now this is RS times PR over VR times sine tatapi. We tatapi lonto mfokamakhamba. So siphaphela thina. Now RS is 36 multiplied by PR. Now PR is basically 7 plus 2, 9 plus 5 sithola bani. Yo 7 yani jonga ngu7 no7 14 nje lena kutheni ndazibhayizisa. This is 9 plus 5 is 14. 14b divided by VR, we calculated now, is 28 multiplied by RW is 7b. So again the b's do the thing because this is multiplication, so 7 disappears, usala 2 phayana. So then ke ngoku into ithi xa kuno 2 phayana u2 kuye uya kayi1. Ndibonisa ibets, uyabona la 2 osala phayana uphinda suke efika nje sekesukile aze apha kusala 14 la. Then sijonge ke ngoku sendiyicomplicatile le nto, andingavelanga ndasebenzisa icalculator. Yeah man, makusuke nje OB apha sivele sifake le nto kwi-calculator simove on. 36 times 14 gives us that divided by 28 times 7. Yo. Aye. 36 times 14 divided by 28 times 7. So I'm getting 18 over 7. That looks a bit better. Remember, this is a ratio, so we leave it as such. Okay guys, so this is how you deal with these kinds of problems. They are pretty easy. So guys, here the substitutions are quite heavy, right? Using the area rule, it's important. And essentially the answers, but some of these substitutions were some sort of calculations, so we can really grant them a mark and say maybe 3 marks, but they may give you 2 marks still. Alright guys, that's the end of our lesson. I wanted to show you some Euclidean geometry for grade 12s. That was shared with me by a student of mine as a homework, but I saw that these questions are pretty hectic. So I figured let us share how to deal with these kinds of problems so that you know that your textbooks are actually a powerful tool. And as you can see, these questions are graded. The previous one was easier. This one was a bit more difficult. And this is usually the mixture that you get in your exams. I hope you guys have enjoyed the video. I will see you another time. Goodbye.